Welcome back, everybody, for another deep dive. This time, we're taking a look at the flyweight design pattern. That pattern that helps us cram tons of data into a limited amount of memory.
Oh, yeah. That one's a classic.
Definitely a classic. We've got some really interesting sources lined up today to help us understand not only what flyweight is, but also why it's so valuable and how we can use it. So you can walk away knowing exactly when and how to apply it in your software designs.
It's a pretty cool pattern, that's for sure, and definitely super relevant these days with all the resource-constrained environments we're seeing with the IoT and mobile-first development.
For sure. It's like Flyweight was made for this kind of stuff. All right, so let's jump right in. One of the key concepts here is this idea of intrinsic versus extrinsic state. Can you break down what that means and why it's so important for getting a handle on the flyweight pattern?
Yeah, so it really comes down to what data is shared between objects and what data is unique to each object. Intrinsic state refers to the data that doesn't change and is common to many objects. Like, let's say you're building a social media platform, right? And each user has a profile picture, and all those pictures need to be displayed as a circle. Well, that circular shape, the mask, that's intrinsic to every profile picture object, it's always the same.
Gotcha. So instead of storing that circular mask data in every single profile picture object,
Yeah.
we could just have one circular mask object and have all the pictures reference that. That's where we get the memory savings from, right?
Exactly. Now, the extrinsic state, that's the data that's different for each object. So in our social media example, the actual image within that circular mask, that would be the extrinsic state because each user has a different picture.
Makes sense. So we have the flyweight object, like our circular mask, that holds the intrinsic data. Then we have each individual profile picture object holding its own extrinsic data. How does that work in practice, though? Where does that extrinsic state live, and how do we make sure it gets used properly?
Well, there are a couple ways to handle that. One pretty straightforward way is to use what we call parallel arrays within the container object. Let's take a particle system in a game, for instance. We could have an array holding all the different types of particles, each represented by a flyweight object. Then separately, we have other arrays to store each particle's position, speed, and so on. Each index in those arrays would match up with a particular particle.
So it's kind of like a big spreadsheet where each row is a particle, and one column points to that shared flyweight object, while the other columns have all that unique data for each particle.
Yeah, exactly. It might not be the most elegant solution, but it definitely gets the job done. Another, maybe more refined way is to create separate objects called context objects. Each context object would hold the extrinsic state for a specific particle, along with a reference to the flyweight object it uses.
Interesting. So instead of the spreadsheet idea, it's more like each particle has its own little notepad with its unique data on it, plus a little arrow pointing back to the shared blueprint.
You got it. And a really important part of all this is that the flyweight objects themselves, they should be immutable. They can't be changed.
Right. We've mentioned immutability a few times now. It's not just a nice to have with flyweight. It's a must have, isn't it?
Absolutely. Immutable flyweights are key for preventing weird side effects when they're being shared between multiple clients. Just imagine if you could change that circular mask flyweight, every single profile picture on the platform would be affected. Total chaos.
Oh, yeah, that would be disastrous. So no setters, no public fields can be messed with from the outside. Everything's locked down at creation. Those flyweight objects are basically set in stone.
Exactly. And to manage these immutable flyweights, we need a way to reuse them effectively. That's where the flyweight factory comes in. I think of it kind of like a concierge service for flyweight objects.
A concierge. Okay, now I'm intrigued. Tell me more.
All right, so picture this. You're a developer, and you need a particular flyweight object. Instead of creating a brand new one each time, you just go to the factory and ask, hey, do you have a circular mask flyweight? The factory checks its inventory. If it's got one, boom, it hands it right over. If not, it whips up a new one, adds it to the collection, and gives it to you.
Oh, so it's like a code recycling program. I love it. But when should we actually use the flyweight pattern? Is it a good fit for any situation where we've got a bunch of objects?
That's a really good question. And the answer is not necessarily. Flyweight is an optimization technique, and like any optimization, there are trade-offs. It really shines when you're dealing with a massive number of similar objects, and those objects have a good chunk of shared data, that intrinsic state we talked about.
So we're not just talking about a few dozen objects here. We're talking about object overload. Thousands, maybe even millions of objects. And the more shared data we have, the more memory we can save.
Exactly. If there isn't much to share, the overhead of managing the flyweights might not be worth the effort. It'd be like using a flyweight to represent the keys on a keyboard. It just wouldn't make sense.
Right, I see what you mean. Not enough shared data there to make Flyweight worth the trouble, but I can definitely imagine how valuable it would be for things like handling millions of particles in a game or thousands of UI elements in a complex app.
Definitely. In those kinds of situations, Flyweight could be the difference between a smooth, responsive experience and a slow, memory-guzzling mess.
Okay, so we've covered the basics of Flyweight, intrinsic versus extrinsic state, immutability, and the Flyweight factory. But before we get into how this all works in actual code, I want to touch on something you brought up earlier. The trade-offs. What are some of the potential downsides of using Flyweight?
Well, for starters, it can make your code a bit more complex. You've got to manage those context objects carefully, and debugging can get a little trickier when the intrinsic and extrinsic state are separate.
That's a good point. It's not as simple as just looking at one object anymore. We have to figure out the relationships between the flyweights and their context objects.
Precisely. And there's also the possibility of a small performance hit. If you're constantly grabbing extrinsic data from separate objects or arrays, it can add a little bit of overhead compared to just getting it directly from a single object.
So like most things in software design, it's all about finding the right balance. We gain memory efficiency, but we might lose a bit of simplicity and raw processing speed.
Exactly. And that's why it's super important to understand the specific problem you're trying to solve and the overall design of your system before you jump into using Flyweight. It's a powerful tool, but it's not a magic solution for every situation.
Right. It's all about using the right tool for the job. All right. Now, before we move on, I want to ask our listeners something. Think back to your own work. Have you ever run into a situation where Flyweight could have been a lifesaver? Maybe you were working on a project that was pushing the limits of available memory. Or maybe you saw a design pattern that reminded you of Flyweight in a totally different context. Share your thoughts with us on social media using #DeepDiveFlyweight. We'd love to hear your experiences.
That's a great idea. Now, let's shift gears for a moment and explore how Flyweight connects to some other design patterns you might be familiar with. So one of the most interesting connections is with the composite pattern. Remember that one? The one where you can treat individual objects and groups of objects the same way.
Yeah, like the classic files and folders example, right?
Exactly. Each file is an object, and folders can hold both files and other folders, but we can work with them all using the same kind of logic. Now imagine you're building like a really complex graphical user interface with a ton of widgets, buttons, and text boxes and panels, all that good stuff.
Okay, yeah, I can see where you're going with this.
You could use composite to represent the whole hierarchy of widgets, and then use Flyweight to make rendering those widgets more efficient, especially if you have a bunch of similar widgets on the screen at the same time.
So like the individual widgets themselves, the ones at the bottom of the tree, so to speak, could actually be flyweights. They can share things like fonts and colors and basic shapes.
Bingo! That's a really clever way to combine these patterns, and it doesn't just stop with composite either. Flyweight can also play nicely with the facade pattern.
Facade, right. Can you refresh my memory on that one? What's the main idea behind facade again?
Sure. So facade is all about simplifying a complex subsystem by giving it a more high-level interface. Think of it kind of like a concierge at a fancy hotel.
Okay, I'm listening.
You just tell the concierge what you need, and they take care of all the complicated details behind the scenes. So you don't have to worry about it.
Right. So it's about hiding the messy stuff and making things easier to use.
Exactly. Now, let's say you have a super complicated system for managing graphical objects, and you want to give developers a nice, simple API for drawing those objects. Well, you could use Facade to create that streamlined interface, and then use Flyweight behind the scenes to optimize how those graphical objects are represented internally. Makes everything run smoother.
Ah, I see. So Flyweight is sort of like the secret weapon that makes Facade even more awesome, like Batman and Robin, dynamic duo.
I like that. And there's actually another pattern that people sometimes mix up with Flyweight, the singleton pattern.
Oh, yeah, singleton.
Yeah.
That's the one that makes sure there's only one instance of a certain class, right?
Yep, exactly. Just like there's only one president of a company, there can only be one singleton object. But with Flyweight, we can have multiple instances of a class, each with different intrinsic states. It's all about sharing, not making sure something's unique.
That's an important difference. So singleton is about controlling how many objects you create, while Flyweight is about using memory more efficiently by sharing stuff.
Precisely. And there's one more big difference to keep in mind. Immutability. Remember we talked about how flyweight objects have got to be immutable.
Yeah, like those objects are set in stone, no changing them.
But singleton objects, they can be mutable. It all depends on what you need for your specific application.
Gotcha. So even though both patterns are about managing objects, they have different goals and rules,
Mhm.
like comparing apples and oranges.
Yeah, good analogy. Now, before we move on, I want to hear what you think about all these pattern connections. Have you ever used flyweight together with another pattern, or maybe seen a situation where combining them would have been really useful?
Yeah, I'm curious too. What stands out to you, listener, about how flyweight plays with these other patterns? It's super interesting how all these design tools can work together in different ways to solve all sorts of problems. Share your thoughts with us on social media using hashtag #DeepDiveFlyweight. We'd love to get your take on it.
All right, so to wrap things up, I want to address a question that comes up a lot when we talk about flyweight. When is it not the best choice?
That's a great question. As we've been discussing, flyweight is meant to optimize things. And just like with any optimization, it's not a one-size-fits-all solution. What are some of the red flags that might tell you flyweight isn't the right tool for the job?
Well, one really obvious red flag is if you're only working with a small number of objects.
Okay, that makes sense.
If you've just got a few dozen or a few hundred objects, the memory savings you get from flyweight probably won't even be noticeable. And it might not be worth adding all that extra complexity to your code.
So it's really about those situations where you have tons and tons of objects to manage, right? Like we were talking about before.
Exactly. Another red flag is if the shared data, that intrinsic state, is really small, or if it changes all the time. If there's not much to share, or if what's being shared is always in flux, the benefits of flyweight kind of disappear.
Yeah, that makes sense. It's like trying to share a single grain of rice. Not really worth the effort.
Exactly. And finally, if using flyweight makes your code way more complicated than it needs to be, and that outweighs any memory savings, it's probably not the best approach. Always remember to think about the trade-offs, the context of the problem you're trying to solve, and the overall design of your system before you decide to use flyweight.
Absolutely. It's like we said before, it's about choosing the right tool for the job. And sometimes the simplest solution really is the best.
Exactly. Now, before we wrap up our deep dive into the flyweight pattern, I want to leave you with a thought-provoking question. So think about the core idea behind flyweight, identifying those shared elements, those commonalities, to optimize how we use resources. Where else do we see that same principle at work? Can you think of any examples outside of the software world, like in everyday life, where we use similar strategies?
Ooh, that's a good one. I'm already trying to think of how this applies to things like supply chains or maybe urban planning or even fashion design. Finding those shared elements, making processes more efficient, reducing waste. It's a really powerful idea that we see all over the place.
Exactly. It's all about coming up with those elegant solutions, right? Maximizing efficiency without having to sacrifice functionality or quality. So as you go about your day, I challenge you to keep an eye out for those flyweight moments happening around you.
I love that. Well, that wraps up our deep dive into the flyweight design pattern for today. We covered a lot of ground. Everything from intrinsic versus extrinsic state to immutability and the flyweight factory. We even talked about how flyweight works with other design patterns and when it might not be the best tool to use.
It's been a great conversation, and I really hope our listeners have come away with a solid grasp of this pattern. It's definitely a handy one to have in your developer toolbox.
Absolutely. And remember, flyweight is more than just a way to save memory. It's a way of thinking about design, about how to find and leverage those common elements to build elegant and efficient solutions.
And who knows, maybe you'll even start seeing those flyweight principles popping up in unexpected places.
I think that's the best part of these deep dives. They don't just teach you new techniques, they change the way you see the world.
So until next time, keep exploring, keep learning, and keep those flyweight moments coming.
Happy coding, everyone!